Hi folks, I'm sitting here in my workshop this morning next to my favorite tool, the Shaper Origin handheld CNC router. I just have so much fun with this tool. I've really enjoyed it. I've used it on a lot of things. The Shaper Origin is sitting on a gadget called the Zed Sled, and I'm going to show you how the Zed Sled can make the Shaper Origin even better. In case you're not familiar, the Shaper Origin is a handheld CNC router. I'm sometimes going to call it the SO in this video. As you move the SO by hand, it makes super accurate micro adjustments to stay on the cut path. Those little micro adjustments are possible because SO can orient itself accurately looking at those little boxes, black and white boxes that look like dominoes. SO is versatile because you can stick those dominoes on virtually any flat surface. There's no upper limit to the size. But the SO does have a limitation in that it rides on its base, just like any other handheld router. If a surface has large open areas or uneven areas, that's a problem for the Shaper Origin. The Zed Sled is designed to deal with that problem. Zed Sled supports the base of the Shaper Origin. With that support, you can make cuts that span open or uneven surfaces. Zed Sled also noticeably improves the accuracy and consistency of cut depths. The cut depth is along what's called the Z-axis, or, for those on the left side of the pond, the Z-axis. Hence the name the Zed Sled. Zed Sled was named by its inventor. I know him as Andrew W.R. from the Shaper Origin user forum. He's been more than generous sharing his invention. He wrote detailed instructions on how to build the Zed Sled. There's a link to that in the description. His projects are absolutely beautiful and inspiring, so I decided to make my own Zed Sled. I'm not going to do a full build video on YouTube. I don't think you need that because the instructions Andrew has posted are quite detailed and complete. There's a detailed thread on the Shaper Origin user forum. If you post a question on that forum, it's pretty sure you'll get a useful answer. I am going to pass along a few specific things I learned building my own Zed Sled. The tape field for Zed Sled is commercially printed on die bond. That's a sandwich of aluminum and plastic. To get a tape field, you use a free online domino generator to create a PDF file in the size you want. Send the PDF file to a commercial printer. The video description has a link to a US-based printer. It's important that the printer not change the dimensions of the print in any way because that'll mess up the size of the dominoes. For that reason, when you send in your print order, be sure to specify no scaling. My Zed Sled is a bit over 1 meter wide, and I ordered a 48-inch by 24-inch die bond print. That was a standard size, and I had to cut it down to fit. I originally built my Zed Sled to use the full 24-inch height of the die bond, but that was a kind of a bonehead mistake. Anything beyond about 14 inches is a waste of space. I ultimately cut my Zed Sled down to size. The frame of the Zed Sled is standard size aluminum extrusions. I wasn't aware of this stuff until I built the Zed Sled. Apparently these extrusions are used to, do DIY 3D printers, laser cutters, CNCs, and the like. The components are made to standard sizes, so things like these corner brackets fit really well. You can look at the build instructions for a list of the parts you'll need. I ordered my parts from a US-based site called Open Builds. There's a link to Open Builds in the description. My Zed Sled is a full 1 meter wide. That's wider than the Zed Sled in the build instructions. 1 meter is a standard length for those aluminum extrusions, so it's pretty easy to make a 1 meter wide Zed Sled. I did have to add an extra brace in the middle where the die bond sheet will attach because it sagged a little bit with that extra width. Both the extrusions and the die bond can be cut with standard woodworking tools. When I chopped the extra height off of my Zed Sled, I just used a track saw to cut the railings. It was easy to cut the die bond sheet on a table saw, but keep in mind that the die bond sheet includes aluminum as part of that sandwich. If you've got a saw-stop table saw, the aluminum's going to trigger the brake unless you use it in bypass mode. I always refresh my memory by looking at the instructions to make sure I'm using bypass mode correctly. The sled itself is built around a piece of carbon fiber. I got mine from Amazon. There's a link in the description. I think some folks have tried material other than carbon fiber, but it needs to have the rigidity of carbon fiber to really hold the shaper origin in a proper position. So the reports I've seen indicate that the other materials were just too flexy. The sled rides on wheels that are specifically designed to fit in the V-grooves of the aluminum extrusions. The top of the sled has 20 by 20 square extrusions, but those create a problem for a Generation 1 shaper origin. The handles on a Generation 1 will ride up on those square extrusions. There are 3 ways to solve the issue. First, you can use 10-20 extrusions. Those are shorter than the 20-20 extrusions I've got here. Second, rounded extrusions are commercially available. And third, you can do what I did, which was to grind away a bit of the railing to give clearance for the shaper origin handles. I used the third approach with a angle grinder and a flap disc. This is mainly because I didn't discover the issue until I'd already built the sled. To use the Zed Sled, you scan using the normal shaper origin procedure. However, the carbon fiber plate prevents the shaper origin's camera from actually seeing your workpiece. It still works fine. You're going to use a grid to place your cutting file, and you can actually make the cuts without the SO screen showing the workpiece. But if you want to see a representation of the workpiece on the SO screen, you can do an add to scan after your original scan. When you hit add to scan, lift the SO off the sled, move the sled out of the way, and take the picture of the workpiece. The SO screen will now show the workpiece. The picture of the workpiece on the SO screen is not accurate. That's not really a Zed Sled issue, that's just generally how the shaper origin is. To accurately place your cutting file, you'll need to do that by making a grid. I made a little demonstration project to show off the Zed Sled. It's a small bowl cut from a laminated block of walnut and maple. I was inspired by some of the beautiful bowls made by Andrew, though my result is not nearly as refined as his. The idea was to use the Zed Sled to accurately cut each layer right down to the depth that just revealed the next layer's wood. The Zed Sled worked great for this. I was able to accurately sneak up on each layer and just take a couple of thousandths off of it until I just revealed the wood I wanted to reveal. I could then use the final depth of cut on a layer to estimate the depth of the next layer. My bowl is pretty small, so in theory I could have cut it on the workstation. The problem is that the shelf on the workstation isn't always precisely parallel to the tape field and support bar. The depth of cuts are far more consistent on the Zed Sled, and that's a big reason to make a Zed Sled. The larger bowls and the chair seats Andrew made would not have been possible on the workstation because they're too wide to support the base of the shaper origin. I've also made good use of the Zed Sled to cut parts that are too wide for the workstation. Now, the Zed Sled isn't necessary for these cuts. You could just use a tape board instead, but the Zed Sled makes it convenient. Well, if you've watched this far, maybe you've got a question in your mind. Is it worth it? Should I make one of these things? The time commitment isn't great. It's pretty easy to make. It doesn't take that long to make. I think you could knock it out pretty quickly without, making a major investment of time. So that part's easy. The part that's maybe not so easy is it's going to cost you about $350 to $400 for the parts. You've got to buy that die bond sheet, you've got to buy this extrusion. The carbon fiber plate is $50 alone. So, I figured $350 to $400 all in for all the parts. For me, that was worth it. Shaper Origin's my favorite tool, my favorite toy in the shop. It's the most fun tool I've got. So if I can have something to have even more fun with it and expand its capabilities, I'm all for that. Obviously, you'll have to decide on your own if it's worth coming up with the money for this. Anyhow, thank you so much for watching. Please leave me comments in the video. I'd love to see those. If you like the video, give me a thumbs up, subscribe, all that stuff. Thanks for watching. Bye.